Okay, then welcome to the 5th practical of ESP. I hope that you can hear us. We had some problems with the microphone and I hope the recording is working, but I think we are loud enough now.
Yeah, very exciting 15 minutes now, but now we can really start. And as you can see, today we have prepared arrays, pointer and strings, so the same that you've seen last lecture from David and Sebastian. That's our plan for today.
So of course we'll start with some organizational matters, especially now with the deadline of assignment 1. Then we'll continue with my swap function from last time and now maybe adjust it a little bit. Then just talk about how we pass arrays and structs to functions. Then about fget. I don't know if you've seen this in the lecture.
Yeah, it was presented very briefly, but we will do an example on that today.
Yeah. And then as always, more in-depth example at the end of the lecture.
And we have a really tight schedule today. We do not think that we'll manage to do everything today, but let's start. The boring stuff, organizational matters, weekly exercises. 3 more exercises are prepared for this week. And the last 3 exercises and the 3 exercises of today are all the 6 exercises that count for assignment 2. Yeah, so basically you need to solve 3 out of the 6 exercises to avoid deduction on assignment 2. Yeah, then the homework and the coding session. This week the homework and coding session 1 ended, and now starting from the next week we open the homework and coding session 2. It's the same procedure as for coding session 1. You need to register to a time slot in a Teach Center, submit the homework before you go to the coding session, and then attend the coding session. The topic will be data structures and algorithms, so it's now a bit advanced, and still it's nothing related to C. It's more a general thing that you know these concepts, that you think about some basic algorithms and data structures during the coding sessions. And now, the thing that everyone waited for, assignment 1 and the assignment interviews. Today I spent 5 hours to automatically grade your assignments, or at least the test cases, and I managed to do this and also assigned you already to one of our tutors. And now the next step for you is to go to an assignment interview. We will announce the dates for the assignment interviews tomorrow, midday, roughly 12 p.m. You will need to register in the Teach Center, similar to the coding sessions, for a time slot. It will last for about 15 minutes, the assignment interview. You will be asked about your code. You will be asked about similar concepts. So what have you used in assignment 1? Loops, conditions, functions. So these are the relevant topics. And the most important thing, you need to be able to compile by hand your assignment. Yeah, so you really need to execute this clang command, and then you need to be able to also execute the compiled binary. If you're not able to do this, you will get deductions on the assignment interview. If you only know how to press the run button in your IDE, this is not enough. You need to do it by hand. But probably you have done this 100 times during coding assignment 1, so it shouldn't be a big problem. Any questions regarding assignment interviews? Yeah?
Yes.
For assignment 1, it is not necessary to bring your laptop already with you because your tutor will present the code. But starting from assignment 2 and 3, you need to bring your own device because then you need to code during the interview. For A1, it's not necessary.
Okay.
Yeah. Now the more interesting stuff, I think.
Let's start, and I'll continue with my example from last time, where we used these structs to swap 2 values in a tuple.
So we'll regularly switch the devices because everyone's do their own thing. Does it work?
Yes. Okay, so just recall this function from last time where we tried to swap two values, but it didn't work. So we had those two parameters, then had this temporary variable, which we saw that we need this, and then we tried to swap them, and they were really swapped within this function, but then we didn't see any effect in the main. Maybe just a recap. And this was because, okay, the stack looked like this, where we just copied the values from the main into the swap function. So, yeah, I think, yeah, x was a, so x was at the beginning 5, and y was 10. Then we swapped those around. And then afterwards, once the function returned, all of this got just deleted from the stack because we returned from the swap function, and in the main nothing changed. And now, as last time you've seen pointers, I think we could think of some way how we could propagate those changes we did in the swap function back out into the main function. Does anyone have an idea how this could work? Yes? Yes, we can pass this by reference and use pointers, as I said. Okay, so let's try this. So we need to make both parameters here to pointers. Okay, so we'll do this. But now if we try to compile it, we see, okay, we still get some errors. That's because we just can't work with those pointers now like with any normal variable. As you've seen in last lecture, we need to dereference those pointers in order to work with them. Okay, so let's try adding those. We have this x here, which is a pointer, so let's dereference it. Then here, okay, here, here. Do we need one here? No, because our temporary variable, okay, it already says this is an error because our temporary variable is not a pointer. But now if you try to do it, it still doesn't work because in this main here, we are passing two integers, and these integers are not our pointers. We want to take the address of both of those to pass them to the swap function. Okay, now it worked, and if we execute it, now the values are swapped. And this might seem like a little bit of magic, but I'll try to draw it again.
Are you prepared the drawing again, yeah?
So maybe it's a bit easier to understand what happens. Okay, so we are passing now, instead of just having integers here, so this x now is not an integer,
to show
but an integer pointer.
Can you maybe move the window a bit to the right that we can also see the code? Yeah, perfect.
Yeah, okay. So what happens now is that here in the main, when we are calling the swap function, we are not passing the actual value of 5 into the swap function, but the address of a. So the address of this variable here. Okay, so this x now holds the address of a, and we could visualize that by just drawing this arrow here, which shows us, okay, this address that we have here, the variable x, holds the address of this a, and it basically points to this a. And then here, the same goes for the y. We're here passing the address of b and not the value of b. So y is now the address of B. And we can also draw this as this arrow to indicate that this variable points to this one. Okay, now this might make more sense now that we need this special syntax to indicate that we don't want to store the address that is stored in this x variable, but really the value in this temporary variable. Because what do we want to store here in this temp? Well, we want to store the value of the first parameter, and if we omit this asterisk here, we would just copy the address. But this is not what we want, because we actually want to store this 5 in a temporary variable. So after this line here is executed, we take the value of A, so we follow this arrow, take this 5 and store it into this temporary variable. This is what this assignment does here with this dereferencing operator.
So basically what we said during preparation for today's practicals, this A is a drawer. And now you go to the drawer with the pointer, you open it, and from the open drawer you take out the value 5. So this is basically this dereferencing or this star operation. You go to the drawer, open it, and then you do something with the content of the drawer.
Yes. So the pointer in this, would be then the number of the drawer where we want to look at and take the value of. Okay, and then here, we of course, if we want to swap those values, we don't want to swap the addresses. We want to go to the location of x and assign it the value that's written at the location of this y, which points to this b. So here, we are really now assigning in the memory of the main function the value of b, which is also in the main function. And then right here, the last line, we are assigning y with dereference, so we follow this arrow, we are here, and we are assigning this the value of the temporary variable, which is 5. And now, once we return from the swap function, again, all of the memory of the swap function is, deleted, freed. We don't have access to it anymore. But now in the main, the two values are really switched. So we really swapped them instead of what we did last time.
Is this clear, or does somebody have a question? Because this is not such a trivial thing anymore, because we really have one more abstraction here where we deal with these addresses and switch based on the arrows here, the values, and not just assign the values directly.
Yes?
This may have been covered before, but I want to just ask. In this example where we have with a star and then with an x, that this means it's a pointer. But could we, in this function, perhaps declare a variable just called x, or would that interfere?
If we name the variable x here, we would create a second one with the same name. Even though they could have different types, this would not work.
It would not work.
Yes. So this would be the same as if you just normally without pointers created two variables called x. Then you get an error. Okay, yeah. So basically, to sum up, instead of working with copying the values of our swap function, we just got the addresses of those variables, and then we could directly access those variables.
Okay. If some questions arise, just knock on the table. We will answer them, and we continue now with the next topic. And I think we stay on your laptop directly.
Yeah, we don't need new slides.
So that the next topic's name is passing structs by reference.
Okay, so now we saw how we could pass integers using those pointers. And if we pass these integers with those pointers to a function, this is called passing by reference, because we're not passing the value of those variables. Instead, we are passing a reference to those variables, which is this pointer. Or you could also think of as we're passing the address of those variables to this function. And I want to start now with something you've already seen. Namely, again, with this tuple struct. And I want to, in the main, create an instant of this struct. I don't know, let's call it values. Okay, so this should be clear. We've done this many times. Now I want to pass this struct to a function, but I want this function to really modify those two values I have in the main. So not like last time with the swap function where we're just copying the struct into the function and copying back out. I want to directly modify those two values from within this function. Let's create a function which will halve this tuple. And as we have seen, if we want to pass this struct by reference, then to go from something which is just a tuple to a tuple pointer, which we'll have now, we need this address of operator. Maybe I will also print this to see if we did something. Oops. Okay, now let's implement this method. So, which parameter does this method take? Well, as we can already see here, we have this tuple and we have this address of, so we have a tuple pointer. And this is exactly what we need here. And let's call it something different from this variable in the name, because it is something different. It's the address of this tuple here. Okay, but how do we access the fields now? You could try just doing this.
So you basically want to divide everything by 2 in this function.
Or maybe something like this to make it more clear. So I want to assign to this first integer in this struct exactly half the value that it has. But as we can already see, this code says, okay, this can't work because we have a tuple pointer, and this tuple pointer doesn't have any field which is called first, because the tuple has this field but not the pointer. Therefore, maybe I'll just write this in parentheses, we need to dereference this tuple. Because here we have an address, we have a pointer, and here we really want the value of those what's stored in this tuple.
So basically the same concept as before. With this star tuple, I open the correct drawer, and then with first, I don't know, I have 2 parts in the drawer and go to the first part of the drawer, for example. Yeah.
You can think of those two operators as just converting between pointers and values. So if we have a pointer, we can use the star to access the underlying value. So to go to the drawer, open it and look what's there, or set something in this drawer. And with this address of operator, we just see, okay, at which address this is stored. And we will create a pointer from a value.
I think this is very nice that we can do this now, but like this star tuple dot first is a bit awkward notation here. Yeah. Have we something simpler here for that?
Because this is so common that you need to dereference a struct and then access a field on it. In C, there exists something to just do both of those at once. And this is just, instead of writing the dot, using this arrow. So maybe with my font it's less clear. This is just the minus and then the greater than sign. And then we can divide this second parameter by 2.
So this is basically
Yeah.
the same as the line above, but written in a more advanced way.
Yeah, I apologize for my font that this is not clear. It does some fancy things.
Okay.
Yeah, so we're using this arrow instead of the dot, and this arrow automatically dereferences the tuple, and we can access the second field.
So
Okay,
you
we
claimed
could-
that this should work. Now let's test it maybe.
I'll compile it, execute it, and yes, as we can see, we now have 5 and 10 in this tuple, and before we had 10 and 20. So our function really modified the tuple that we have in the main, and like with the swap, we did something in a function, and this affected what we had outside. And yeah, this is the power we have with pointers.
I have a question. So in line 11, we did this dereferencing stuff and we used the brackets and then just dot first. Is this important or could we just leave out the brackets here? So if we just write it
Yeah,
without.
you mean like this?
Yeah.
I think this code will tell us, yes, exactly. No, this does not work. And if you remember the second lecture, probably operator precedence. So which operator binds more strongly than some other operator, then we know that this dot has, I think, a higher precedence than the star operator. So if we leave out the parentheses, it's as if we would write this, and as we have seen, this does not work. So if we want to do this without the error, we'll need to include those parentheses, or else, the dot operator would be applied before the star operator.
Do you also have a picture for that?
Yes. Okay, I just want to quickly draw this again like I did last time. I hope. Yes, I have this here. Okay, so this is what we have in the main. We have this values variable. And like last time, I just drew this with this box to indicate that this is a struct and consists of 2 integers.
Now, I need to complain now because you already have the solution there. Maybe first has now the value 10 and 20. Second has the value 20. Yeah, that happens if you test everything already before the lecture.
Okay, but now if we pass this into our half function with this address of operator, what do we have in here? Do I need to again draw this struct like this? Or does anyone have an idea what we have here now, or what this, how did I name it?
The tuple.
What the tuple in the half function is? Yes? Yes, it's the address of the tuple. So here we don't have any struct like this, because when we take this address off here, we are just getting the address, and the address is always the same size, and even if the struct is big, the address is just the address. So we have the address of, I'll abbreviate it, of values in here, and not the actual struct. And like in the first example, this now points to the struct here. And now, when we do in this line, when we access the first, so we dereference this tuple, we are here, we dereference it, we follow this arrow, we access the first element, and then we do the same thing again and divide it by 2. So this is 5 now. And here, both of this happens at once. We are at this tuple. This arrow operator dereferences this for us. and we access the second element and divide it by 2. So it was 20 and is now 10. So very similar to the swap example. But yeah, we can also do this with structs. That's basically the point of this example.
Any questions?
Yes?
Do the first and the second parameters in the struct have their own addresses?
Yes, the first and the second parameters in those structs have their own addresses.
And are they different from the address of the struct or the same?
So if you take the address of the second field here, it'll most probably be a different one. Then it is different than the address of the first one because there are 2 different values. And yeah, and the first field in here will probably have the same address as if you take it of the whole struct. So, I mean, you could do something like oops. So here we're taking the address.
Now you don't need the arrow now because we don't have a pointer.
Oh yeah, we don't have a pointer here. Oops, I was in the function above.
So values is just the struct itself, so we just need the dot here.
Yeah, here. I wanted to type this here.
Okay, so we do it here. So you dereference
So now you
the
see
tuple.
both. That's how we can get the address of the second field of this tuple. So very straightforward. And that's, yeah.
But now it's in a second. But now if you do this, what you've done now, with the tuple second and the end before, so the address of the second element, then this is of course not a tuple pointer anymore. It's then just an integer pointer because we just go to the address of an integer and not of a whole struct.
Yeah, because values.second, we can see here is an integer, and we are taking the address of that, so we have an integer pointer. So, like this.
Yeah, there was a second question. Yeah?
Okay, so something I just want to understand about pointers is when it comes to taking, so if we, in the function, when we call the function, we have the, let's say, the address give with the little notation there. And so this address goes up into the declaration of the tuple and then the pointer of the tuple. My question is just, if this address is some value numbers, and it gets then put into the pointer, why do we have to declare it as a pointer? Would it not, because this little star, I suppose, works a bit like an operator. So why can't we just declare this tuple without the pointer, and then later on make it a pointer?
So is,
Question repeat.
yeah, okay, so the question was, if we take this address of this values tuple here, and why, yeah, because if we take, I try to rephrase the question. Okay, so if we when we take the address here, we just have an address. Why do we need here to write tuple pointer? Was that the question?
Yeah, why can't we just declare tuple, have this address as a value, and then we down, when we're writing it, then we write the little arrow or the little star, and then this pointer. Why does it have to be declared as a pointer right away?
Yeah, okay, so why do we need to have it as a pointer here? Well, because if we do it like this, then this half function expects something completely different. Because right now we are expecting 2 integers within this tuple here, but we are getting an address. So this is a different data type, and therefore C will complain because they could have like different sizes, and now the compiler doesn't know what to do with it.
So could this potentially work if it wasn't such a data type? Perhaps if it was an integer?
Okay, would this work if it wasn't such a data type, but maybe a more simpler one? It could. So you can cast normal data types to pointers and then take the address of just a value that was in this variable. But in general, we should not really do this because this can lead to any sorts of weird things that happen. But this can work, yes. But we'll not go into detail now.
Further questions? Otherwise, we maybe switch now again the device. So now we have seen the swap function with the call by reference. Yeah, so we can access the values in the function. Then we have seen it with the struct. Now the question is what happens with an array in this case. Yeah. So when we pass an array as a parameter to a function, yeah, so I'm not that creative as you, I just have it on the slide now. So for example, we have an array here, pass it to a function. So this is the function declaration. The array will always be passed by reference. So this means the array that you access in the function is the same as it is outside of the function. It's always called by reference, it's never a copy. And there are two ways to do this. You can either pass it as a pointer, so you have the syntax here, you pass your array and it now becomes a data type pointer. Or if you like it more in this notation, you can write that it's still in the array syntax. Yeah, so you have expect really an array and not a pointer, and they are completely the same. So passing an array to a function is always by reference, and we will see this later in the examples as well. Now I have a warning here as well. Never return an array from a function. And this is quite important. I think, do I have a code? No, I have it here. Yeah, this is the code. So assume we have here our function f. We have an array of size 4 in this function. And now we say, okay, we return the array from this function. Okay, maybe this is an integer pointer then, not so sure what an array as a return type should be, but maybe try it with that. And we get now this array in our main function, and I want to do something with that. And there we really have a large problem because this doesn't work. Yeah. Why is this the case? Because if we declare an array here, then it just lives in this function. So we have the memory contained in this function. And if we return it then, we always said this in the examples that the memory of the function is deleted. So we do not have the array anymore. But still we want to access the array then later on in the main function. This cannot work. Maybe we can go to the drawing back. I'm sorry about the switching always.
Do you have a drawing for that?
Yeah. Open it on your laptop. Yeah. So that's my drawing. And we had this function f here. We have the array f that lives in the function of the size 4. And this is the state when we are in the function. Then we can access the array, write something to the elements of the array without a problem. When we now return the array, this would be then similar that this array variable here just becomes a pointer to our array here. Because arrays are always handled by reference. So this will not be a copy, it will be just handled by reference. And then, when the function f is complete, yeah, this function is complete, everything here gets removed. Okay? So we end up having the array in the main function. And what is the problem now? The problem is that our pointer that points to the array points to somewhere, which is not there anymore because the function f terminated. And that's the reason why you should never return an array from a function. Never do this. Because you don't have the memory anymore. Yeah. Okay. I think that's it with the drawings. No, it's not it for the drawings. But move on. Yeah. We need maybe find a better setup for the drawing. Okay. Next thing, fget s. You have seen this in the lecture very briefly, and we will discuss about it a bit more detail. And I was a bit lazy here, because the definition that I wrote here, I just copied it out of the official documentation of fget s. And what does it do? So this is the declaration of the function. It's a bit more complicated than what you've used in assignment 1. So this is again just simply the return type, and it takes 3 arguments here. And now we just read what it does. So the fget s function reads in at most 1 less than size. Okay. Size is this second parameter here. 1 less than size characters from the input and stores them into the buffer pointed to by s. Yeah, so it takes size minus 1 many characters from the input that the user enters and stores it into this array that we have to create before. It stores it into this array. We have a bit more. Reading stops after a new line. So if we have size of 100, but the user just enters 3 characters and then a new line, then we just read the 3 characters and the new line, and then we stop. So in this case, we do not read 100 minus 1 characters, but just those 4. So moreover, if a new line is read, it is stored into the buffer. Yeah. So when the user enters the new line, also the new line is stored into the buffer. A terminating null byte is stored after the last character in the buffer. Okay, so remember last lecture we had the strings, and a string is always terminated by a null byte. So a byte where all the bits are set to 0. A byte which has the value 0. So that's why we call it null byte. And fget s already does it for us, so it stores the user input into the buffer, and it additionally adds a null byte at the end. So this is a quite convenient function. Okay, I think that we can now test the function a bit. So I've prepared also a main. Hope it's large enough. So we want to read now an input from the user. And we need to store it somewhere. So we need array. So we call this maybe directly buffer and make it of size, maybe 5. So we have now our array of size 5. And now we want to read a user input. So we call fget s. The first parameter was the buffer. The second parameter was the size, and the size is now the same as the size of the buffer. It could be smaller, this is okay if you just want to read in shorter inputs, but it should not be larger than the buffer, because you can only read like 5 characters at most into the buffer. And then you need to specify from where you want to read something, and we will always write stdin now for the next month. So stdin is just the user input. Okay, now we have this fget s with the buffer, with the standard in. And now maybe we print the content of the buffer. So you just write your array, what is the correct format specifier, %s, and maybe we also add a \n here. So this would in theory work now. I want to be a bit more precise now. I also want to do a for loop now over the buffer. over the size of the buffer, and print the value of the character that's stored in the buffer, as well as the character that's visible for us. Maybe do it like this. So we print buffer at the position I, buffer at the position I. Okay, so in this case we just print the string, and in this case we really print all the 5 elements of the buffer to visualize this and to have a look on it now. Okay, then we compile it. Yeah, this worked. Main, okay. And now we do some user inputs. Yeah. For example, I just type in 2 characters, character 1 and 2, and I press the enter button. And what is now the content of the buffer? The content of the buffer is, okay, first we have the character 1, then we have the character 2, then we have some weird character that does a line break. Okay, this is clear because I also pressed the enter button. So this is the enter button that I pressed. And the next element in the character is certainly null, and then there is something which we did not use. Yeah, because our string is just the 1, the 2, the new line character, yeah, this weird character here, terminated by 1 null byte. That's the user input.
So the string actually ends before the buffer ends.
Yeah, so they do not have the same size here. The array has size 5, and the string has size 3 plus null byte. Now make a different user input. 1, 2, 3, 4. Okay, now let's see what happens. So in this case, we have the first element is the 1, the second element the 2, the third the 3, the fourth the 4. But then I hit the enter button, but this is not stored into the buffer anymore. Why is that the case? We said here fget s reads in at most 1 less than size characters. And now we have 1, 2, 3, 4 and the enter button. These are 5 characters, but it reads in only 4. So only the first 4 are read in, and the new line character is not read in anymore. Because, very simple reason, we need to have the null byte at the very end. And now, if I can make the user input even larger, I don't know, 1, 2, 3, 4, 5, 6, then we always have 1, 2, 3, 4 stored, and then it's cut off. What happens with the remaining part of the user input? So with the 5, 6, and then the \n. Yeah? Yeah, exactly. It's stored into the input buffer. So we also had this when we used scanf and characters, where the \n was always there. We also have the same situation here. The 5, the 6, and the new line are still in the input buffer. Yeah, I can do this like this. I call now a second fget_s, store it in the same buffer, again 5 from stdin. The first one is just printed. The second one is then really analyzed with the for loop. If I execute this now again with the same input, 1, 2, 3, 4, 5, 6, then first note, I just entered 1 user input. Second, we have in the first printf the string that we already know from 1 to 4 with a terminating null byte. Then the remaining part of the input buffer is read in, so the 5, the 6, and the \n. Then we have a terminating null byte, and here is some rubbish that we do not care about. I hope this is clear, what happened here.
I think one of the most important takeaways here is to always remember that your string has this null byte and that you need some space for it. So that your array always needs to be one bigger than the amount of characters you want to store in the string.
So if you, for example, here expect an input of 3 characters at most, then the buffer is large enough because you have the 3 characters, the \n, and the null byte. 5 works out. If you can expect that the user needs to enter inputs of length 4 at least, then you will always have this \n or some further characters which are still in the input buffer but not in your buffer. So a situation that you probably don't want to have. Okay. I skipped the drawing now. I hope this was clear enough.
Yeah, I think we've already drawn this many times with the input buffer.
Yeah.
With the characters, yeah. And it's the same concept, just with the whole string.
So we have seen this. Yeah. This was now the more theoretical part. Now we come to the more practical part of today. And we do a bit more about coding. And I think we have a similar exercise on the weekly exercises where you need to reverse a string, but we will do it now in a better way because I think you only need to print it in reversed order at the weekly exercises, but we really revert the string now in our memory. So basically, this now combines everything that we've seen so far in today's practicals. We need to read in a string from the user. Yeah? So we use fget. We then print the string. Okay, that's already known. We need to reverse the string. And in particular, when we want to reverse something, we need to swap characters in the string. And swap have we seen today. And then we again print the reversed string. Okay. Let's start coding. So maybe we make it now a bit larger. I don't know. 20 characters or 100 characters, so the input should be large enough. And then we read it also with fget. So we read 100 characters and yeah, we print the input. Yeah, so far so clear. We have an input and we print it. Now I want to remove the new line character, but I don't want to talk about it now. So I just will copy now from a solution the remove new line function. Don't look at it. We will discuss it later. I just want to accept it that it exists. So bad stuff, go away. So I have now a function that takes a string as an input and it just removes the new line because that's a bit awkward otherwise. So we just remove the new line, pass in the buffer, and now the new line is removed. And we're sure about that. We only have the string until the null byte.
Yes, because if we would reverse the string with the new line character, then we would have the new line character at the beginning, and we don't want that.
Wouldn't make too much sense, yeah. Okay, now we've seen, last practicals I think, always split everything into functions. So write a function that reverts the string. So reverse string, and we pass in our buffer now, because there the string is stored that we want to revert. We declare the function, so it should not return anything. We reverse the string, and it takes a pointer to the string, or we could also write it as this. We could also say it takes an array of some length that we do not know. But I probably stick with this notation now.
Yeah, so we really see what's happening because we are passing this pointer.
Okay. Now we have the reverse string function here. The array is, remember we said this, is passed called by reference. So if we modify the string now in this function, then the modifications will also be present here in the main function. Okay. Now we need to find some algorithm that we can reverse the string. And a good start could be that we take the first element of the string, or we take the last element of the string, and swap them. Because then the last element becomes the first element, and the first element became the last element. Okay, so for this, it's already true that it's reverted. And then we do it with the second element and the second last element. We swap them, and yeah, the string is, those two characters already swapped. And then we do this and do this and do this again and again. And when we always swap the characters, at the very end, we hopefully have a string that is swapped. Okay, now let's implement this. The first thing is we need to know the length of the string. And have we seen this in the lecture? Is there the string length function? Have we seen that? We have seen this, okay. Okay, yeah. So the string length of buffer gives us the length of the string. The length of the string could be much shorter than 100 characters. And maybe call it length and store it into this variable length here. And now we said we iterate and swap the characters. So I will iterate here over the string, less than length maybe. Okay, now I want to maybe make an example here. Let's write our lecture hall today, and this is position 0, 1, 2, 3, 4. So these are the indices of our string. So this is index 0, index 1, index 2, index 3, index 4. And now we want to swap 0 with 4. We want to swap 1 with 3. And we want to swap 2 with 2 question mark, or do not swap it. Doesn't matter in this case. Because then the 0 and the 4, if we swap these, then we have the 1 at the beginning, the H at the end, the P here, the S here, and maybe something in the middle or not. What do we observe here? We always swap the element 0, 1, 2, so we can use here our index I. So we can do something like swap buffer at index I and take the address of it, because we said swap function needs call by reference, so we take the address of it. How do we get to the 4? The string length of this string here, it has 5 characters, so the string length is 5. When we just take a buffer at length minus I, then the length would be at the very beginning 5. The I is 0, so we would have here the value 5. But we need the value 4, the index 4 at the beginning. So we'd need to take length minus 1 minus I. So length minus 1 is already 4 at the beginning. If I subtract 0 from this, I get 4. If I do it in the second iteration of the loop, then I has the value 1. Length minus 1 is 4, minus an additional 1 is 3, and this is exactly the index that I want to swap with. So this should be the right index here. And we again take the address. Okay. Then we do not need to return something from this function because we had call by reference. So we can just say, okay, this works. We iterate over the string, swap everything, and we get the result here in the main, and maybe we copy the printf. And now we are hopefully done.
So before we execute it, maybe, I don't know, everyone who thinks that this will work, raise their hand.
Either nobody,
Okay. So, and who thinks this doesn't work? So, okay. So assume we implemented the swap function. Who thinks this won't work?
Oh, I forgot the swap function.
Yeah.
I'm sorry, yeah.
Assume we've implemented the swap function. Who thinks this won't work? Okay, 1.
I copied
Okay,
it.
then let's try.
Yeah, I just copied my swap function. I'm sorry, I really forgot it. I wanted to copy it, but I was a bit lazy. Okay, we swap it here. Yeah, swap function is as we've seen before. Compilation.
Yeah.
What is the problem? Yeah. Yeah. Okay, we include the library.
Maybe this was the reason someone thought you did something wrong.
Not string length, string.h.
Yeah.
I'm sorry. Nah?
Who now thinks this works?
More and more people raising their hands. They have trust in me. Okay.
Let's try.
Yeah, compilation without a problem now. Run it. Now take this as an input maybe. The first is the input. The second print is the without the remove line, without the new line, okay. Last one is reverse, but it's still the same.
Has anyone an idea why this doesn't work? Yes?
It swaps everything twice. So it's back to the original.
Yeah, this is exactly the reason. Everything is swapped twice, because I iterate with the I from 0 to the length. So I do not stop here with swap 2 with 2. I actually do swap 3 with 1 and swap 4 with 0. And then everything is swapped twice, so it doesn't work. So we don't need to...
Yeah, so we are basically reversing the string twice. Once from the front and then from the back.
The solution is just iterating over 1/2 of the string. So we just stop at length divided by 2. Length, the half length of the string. Okay, now let's try it again. Compile it, run it, lecture hall P1, and now it's reverted. Yes, it works. Very nice.
So do we need to be careful because we're dividing integers here?
Yeah, in this case, it's no problem if the length is odd, because the indices will always be even. And yeah, if we would make an example here with, now we already have an odd length here because the length is 5. 5 divided by 2 is 2. 2.5, but it's just 2. So we swap 2 with 2, nothing bad happens. And if it's an even length, so it's just length 4, 4 divided by 2 would be again be 2. We have to swap 0 and 1, this is fine. Okay, so this works now. Very nice. Any further questions regarding this example? Now we're left with this mysterious new line, remove new line function here. Do you want to have the, So,
No,
you go here. Okay.
Okay, so maybe I already said something earlier that the string doesn't have to be the size of the buffer, as we've I think seen 2 times now. If we just set this 0 byte earlier, then we can actually shorten the string without shortening the buffer. And this is exactly how implementing such a remove new line function could work. If we look at it now, well, okay, we take the length of the string, and str_len returns really the length of only the string. We can, check if the last character, we need -1 because his length, for example, is 5. And then the last index of a string with 5 characters would be 4, because we start at 0. So we need -1. And if we have a new line there, we can just set it to 0, or which would be the same as setting it to this. So we're just setting, replacing this new line character with this 0 byte, which already tells us the string now is like ends here. So we have now 2 0 characters, because we had one before we had new line 0 character, and now we have 2 0 characters, but this doesn't matter because the first one already tells us that the string ends here.
So after this operation, also the string length would decrease by 1.
Yes.
Yeah.
Okay, then should I do my example?
Yeah, we have 10 more minutes. You do your example.
Okay.
Yeah.
What was the size underscore t type?
Oops.
Removing line function.
Yeah.
What?
Good question. The size t in the new line.
Oh, yes. Okay, so the size t is basically most often just a long integer, and you use this type. I know if, we can see here string returns a size t. Up here we just use an integer. This is also fine. The size t is just bigger than an integer and guarantees us that we can store every number there with which we can index an array. So basically it's just the size a pointer has on the system.
Yeah, we said we have integer overflows, and if our array would be larger than the maximum number an integer can take, this could be a problem, but with the size t this never occurs.
Yeah, but if you want, you can also just use integers because you won't be working with such large arrays. Yes? Yeah, right. I was already, I wanted to ask you this earlier.
Okay, yeah.
In here, if you have this myString and we're accessing it at length -1, myString is a pointer. Why don't we need to dereference it?
Yeah, so myString is a pointer. An array is also a pointer. Yeah, in both cases, we just have the information where the array starts. If we just have a pointer, it's the address of the first element of the array. And basically both is now the same for us. If we have a pointer, array, there is no distinction. And now we would need to dereference it to get the element. But of course, if we have now length -1 here, for example, it's not enough to dereference the pointer, because we need to go to the respective element in the array and dereference it, dereference this address then. And this brackets exactly does this. It takes the start of the array with myString, and it goes to the correct element, length -1, to this address, and then does this dereferencing thing.
So this is similar to this arrow, just dereferencing it for us.
Is this clear, or is it not clear? It's okay if it's not clear.
Okay.
We will discuss it also in the lecture once more.
Yeah.
Yeah. This was yours. Oh, this is now mine. Okay, so what I want to do, we already saw this. I want to do something a bit more. I want to read a string from the input, and I want to look at the first word of the string. And if it is echo, I would just want to print out the same string again. And if it is reverse, I want to reverse the string and then print out the reverse string. So something like you're familiar with from the command line, where the first word determines the action you want to do, and the second one is the parameter. So the second one will be our string, and the first one will be either echo or reverse. Okay. So I'll just write this in the main how I want to do it. I want to have some function where I can split this string. Because I would just want to look at the first word, but we have a string with multiple words. So for example, we have something like this, and I just want to look at the first word. I want to compare this word to echo and check if it's echo, and to reverse to check if it's reverse. And then, based on that, I want to do something with this. And now my idea would be that I pass a pointer to this string, to a function, and this function will then insert the null character for the first space, and then return the pointer to this character. And now if I hold on to the original pointer in the main, I'll have one pointer to the beginning, and this string will now just be echo and end at this null byte, and one pointer, which is the new one, returned from my function, pointing here, and this will basically point to our argument. And yeah, so we basically have two strings in one char array. Okay, and this would look something like this. I just want to pass my buffer, and then...
So just to repeat this one more time, the return value of this split string function should be then the address of the age in HSP1. Okay.
Yeah. Okay. And now I want to implement such a function. Well, we need to return the char pointer, which will be the pointer to our arguments. And of course, we take a pointer to our buffer. Okay, so yeah, how do we do this? Well, we of course need to loop through our string and then check each character if it's a space. And if it's a space, I want to replace it with this null byte, like here, and then return a pointer to the element right after the space. So we need to loop through this. So current character will start at the first one, and I'll write it in the second line. And we want to loop until we're at the end of our buffer, because maybe there is no space, then I want to loop to the end. And here, in the second condition of the for loop, right, I want to do something like this. I want to loop until I find the 0 byte in my string.
Why is this the end then of the string?
Because we always set the 0 byte at the end. That's how we find the end of our string.
So as long as we basically do not see this 0 byte,
we know that we are still within the string and have valid characters.
Yeah, that's an idea on how to get to the length of the string.
Yeah, I could have also used len, like you did. But I want to do it like this. And now we just need to check if this current character, if the buffer at the current character is equal to a space. Your keyword. And if it's equal to a space, I want to replace it with this 0 byte, as we've seen here. Like this. And what do I want to return? Well, I want to return the pointer to our arguments so I can access them after. So we need the buffer. but not at the current character, because the current character is the null byte of our first string. So I increase it by 1. But now I just have this character, and I need to take the address of that, because I want the address of this age here. And with this, we get this age. We set the space to the 0 byte. With this one, we get the age, and I want to take the address of the age.
Okay, this is a lot. Yeah, okay, I see. So the buffer at current character would yield us the null byte. Buffer at current character plus 1 is the age. And now the end before that we write in front of the buffer just says we don't take the age itself, not the character value, but we really take the address of it.
Yes. And now we can use this here.
Okay, so we're already done in the function above, more or less.
We did what we wanted to do. We replaced the space with the 0 byte. We now have 2 strings, one here, and we're returning the pointer to the new string. And now in the main, I just need to check. I think you've already seen this with string compare. If our buffer, did I say string compare?
Yeah, they did.
Okay.
They did.
If our buffer is equal to reverse, so if the first word is equal to reverse, and it returns 0 if they are equal, then I want to reverse it, and if not, I just want to print out the string.
And you probably want to just reverse everything after the
Yes,
reverse.
I don't want to reverse the buffer, which would be the reverse. I want to reverse the arguments.
And you want to print it probably as well.
And I want
yeah.
to print the arguments, yes. Okay, let's try this. Yeah, we have one warning because I didn't return anything here. If our for loop doesn't just ends, so we get to a 0 byte without finding a space, we could just return the original array. Okay, so
Not input.
let's try with echo first, and we get the same string back. Let's try with reverse, and we see that we get the reverse string. Yes.
Yeah, it looks a bit like magic, I must admit. I think we will go through this next week again, because this is really hard. And
Maybe I'll prepare a drawing of what exactly happens here and how we replace this white space.
but maybe think about it. So, question, yeah?
Yes, so earlier you said not to return the array, but please do not return the array.
This is a
Oh,
very,
yeah.
very good question now. And we said this, and this is completely true, that we should never return an array.
But we not an array, but an array that we created within this function. So this works because what we're returning here and what we're returning here points to this buffer. And this buffer still exists after we called this function because it exists in the main. Because basically we're just returning an array we got as an argument back.
So this, when we return something from this function, we do not return an array. We just return the address of the first element of an array that existed already outside of this function. So we don't have the problem that after the function terminates, the array is gone, because we created it already in the main function. It is really tough, we know this, and I also have now the feeling that we did really a lot of things today which were not easy at all, and is particular through the last example we will go through next week one more time, because this is, it's really a lot of things happening, and we want to visualize this.
Yeah, I'll draw this function of why we can return this pointer.
Okay, maybe back to the slides for a very last second. What have we seen today? A lot of things. We started with the rather basic swap now compared to the last example where we saw this call by reference stuff. we talked about passing a struct per reference to a function, and yeah, then we dived into arrays. We put them as parameters and return values. We talked about fget, and then we did the string reversion and even more advanced things now at the very end. Now we have like 10 more minutes until the lecture starts, and we can also use them at least partially for general questions. So please ask questions now if you have any. And you can also come to us when you stop the recording, ask us questions. This is really no problem. So any further general questions? Or everyone wants to go into the break, probably. Yeah, I think then we are done.
Okay.
But thank you.